All right, so tomorrow we're going to be in the lab and we're going to be doing this reactions lab. So we'll be mixing some stuff together and seeing what happens. Nothing is going to explode in your face, okay, or do anything really, well, there might be some surprising stuff, but nothing dangerously surprising. Okay, there will be some very obvious changes in each and every one of these reactions. Okay, I'm not going to have you mix two things together and have nothing happen. All right, so if you have mixed two things together and it appears as though nothing has happened, you may have mixed the wrong two things together, or you simply haven't been observant enough. Okay, what are the signs of a chemical reaction? Quick review. Caroline? What? Oh, now you can't think of it? Color change. Change of temperature. Smell. Okay? What else can happen? Sometimes we get this stuff forming and it kind of falls out of the reaction. Starts with P. Precipitates, right? We might get a precipitate. You could get foam. Foam is bubbles. Foam is evidence a gas has been formed. Okay, a precipitate also evidence that something new is formed, because before, obviously, everything you had was soluble. Suddenly, you have something that's not soluble. Okay, so these are all signs of a chemical reaction. All right, so that's kind of part of what we have to talk about in our hypothesis. All right, so the problem we're investigating is when substances are mixed, the chemical properties of each material determine whether a reaction occurs. The evidence we have, okay, is that there's new things created. These new things have new chemical and new what? Not just chemical properties, but also new physical properties. If they're different, they have to have different physical properties as well. Those are things like color and odor and state and all of that kind of stuff. Solubility. These are all physical properties. Okay? That's why those things we just talked about are the signs a chemical reaction has occurred. They show us that there are new materials with new properties present. All right? So our variables here, we want to identify our manipulated, responding, and controlled variables. In this experiment, you are simply going to be mixing chemicals together. All right, so each time you make a mix, okay, there will be a new pair of materials. So what are you doing different every time? Every time you pair two things up, are they different things? Yes, okay, so that might be what you're manipulating. Okay, is that your starting materials for each reaction are probably different things. Okay, your responding variable, what happens? Okay, you tell me, what's your responding variable? What's going to happen if you're always mixing different things together? All right, and then your controlled variables are those things that you do the same every single time you mix materials together. Okay, are you mixing them in the same place? Are you mixing them, you know, what else is kind of the same in that room? Okay, that might affect things. All right, we are going to make a couple of changes, okay, from the first lab. In the first lab, we used that little depression plate, and our biggest complaint was the tiny amount of everything we had to deal with. So tomorrow we're going to be using slightly different stuff. We will not be using the depression plate. We'll be using what's called a watch glass. It's about this big. Looks like a big giant contact lens. Okay, it's just a big concave piece of glass. Okay, it's like a dish, and you can do your mixing in there. All right. Recommendation: when you're doing the mixing, okay, the tabletops are black. Sometimes you might get a color change to a dark color. You might not notice that against the dark background. So you may want to, you know, try it against a white background, put it on a piece of paper, okay, and then move it over to the black background, right? You could get maybe, let's say, a white precipitate in one of the reactions. Well, you might not see that on top of the paper, so each time you're doing a reaction, make sure you check it against a dark background and a light background, just so you don't miss anything, okay? So in our hypothesis, we want to generate a hypothesis about how we can deduce that a chemical reaction has occurred when two substances are mixed. Okay? So the if part of our hypothesis should probably talk about what determines whether a chemical reaction happens or not, or what is a chemical reaction. That's what we should say in the if part. Okay? The and part is what we're doing in the experiment. We're mixing different pairs of things together. All right? The then part should probably talk about how will you know if a reaction has occurred. So the signs we talked about, what are they? Okay, will they appear? Will they all be present every time or not? Okay, so that's kind of your pre-lab stuff. You do not have to have the design, hypothesis, and whatever else. You do not have to have that ready for tomorrow. All right, that you can wait to do until you're doing the whole report. What you do have to have ready for tomorrow are 2 charts. Okay, you are going to need a reactions lab predictions chart. Okay, that has the reactants for each of the reactions. Now I put the reactants on here. Okay, because, well, I put the formulas on your lab sheet. It's not a secret. Okay, these are the formulas of the things that you will be mixing together. All right, so you'll have a chart that looks like this: pair 1, pair 2, pair 3 to pair 7. All right, and you'll put in the reactants, and you predict what you think the products will be. Okay, and then we'll be comparing that to what we see actually happen in the lab. All right, you do not need to predict for pair 4 or for pair 5. This is an indicator reaction with phenolphthalein. If you've ever watched CSI, it's the stuff they put on the cotton swabs to see if blood is present, turns pink in the presence of blood. Okay, that's phenolphthalein. That's what we'll be using, okay, tomorrow as an indicator. But we don't talk about indicator reactions in Science 10, so there's no way for you to predict what happens in those 2. All right, so you don't have to worry about pair 4 or pair 5. All right. Now, looking at some of your predictions here, okay, pair 2 is one you've probably seen many, many times. Acetic acid and sodium hydrogen carbonate. This is like your grade 2 science lab that you did. What's the other name for acetic acid? You might put it on your French fries. Not ketchup. Vinegar. Vinegar. Okay? Some people do. I don't know. Some people put mayonnaise on their French fries. I don't know. Okay? So vinegar, and what's this stuff? Sodium hydrogen carbonate is also known as baking soda. Okay? This is vinegar and baking soda. Except it's not vinegar and baking soda like you would buy in the store. I mix it super good. Okay? We have stuff in the lab that is glacial acetic acid. It is about 1,000 times more concentrated than vinegar you buy at the store. All right, so yeah, it's good stuff. All right, you have to be careful with it. It will take your skin off of you. Okay, you have to be very careful with the stuff that we'll be working with tomorrow, including this stuff here, hydrogen chloride in pair 7. That's hydrochloric acid. Okay, also very concentrated. Okay, burn the skin right off of you. So is this stuff, sodium hydroxide. It's the stuff that's in oven cleaner. It's mixed stronger than oven cleaner. Don't get it on you. Right? You don't want a chemical burn from any of these things, so please be careful with everything tomorrow. That said, might not be the best day to wear your favorite outfit. All right? If you spill something, that will probably be the end of it. So you might want to wear something a little less than your favorite. Plus, we got the lab aprons in there as well. All right? So you're going to write these reactions down. Predict to me the products. Okay, what kind of reaction does it look like most of these are? Okay, you predict the products as we've talked about in class. Cam, question? Will we what? You will not be. I had to make it concentrated enough that you can see what happens in the reaction. A little bit. Yeah, I won't say I did a lot. I watered it a little bit. All right, the other chart you're going to need looks just like this one, except it's for your observations. All right, so you're going to just go onto Google Drive tonight and set up the chart and then copy it and make it again and just retitle it. All right, don't put the reactions in the boxes this time. This way you'll have room to write a before and after description of each reaction. All right, so you could say, you know, before the reaction, both materials were clear solutions. Okay, after the reaction, there was a white precipitate, okay? Something like that. Those would be, you know, there was a temperature change and a white precipitate was formed, something like that, whatever. Okay, you tell me in your observations here, just kind of anecdotally, that means write down what happened, okay, in terms of your observations there. Everybody follow? Okay, so that's what you need to have ready for tomorrow, those 2 charts. It's really just one chart, okay? You only have to build one chart, just put different stuff in it, okay, for each reaction. All right, does that make sense? Okay, make sure you have those ready to go for tomorrow. Okay, do them on Google Drive tonight, print them off, okay, or draw them by hand, and then you can do them on Google Drive later because you're going to have to hand this all in electronically, same as you did the first lab. All righty? Okay, you will not be able to go into the lab until I see that you have the predictions and the chart ready to go. All right, we still have 10 minutes or so left in class. Okay, couple other things to talk about here. in terms of what's going on in the lab here. Okay, these are the pairs. Okay, again down here, make sure you're mixing the right things together tomorrow when we get in the lab. Okay, and then the analysis. Okay, in the analysis says using words and formulae, write the chemical equation for each chemical reaction that occurred, not your predictions. Now, if your predictions were right, you're great. Just copy and paste it down into the analysis, okay, making sure that it's balanced when you write it out in the analysis. Everybody follow? So you're going to have these reactions right after your hypothesis. Your prediction box will go there, and then in the analysis, you'll have the reactions written as they occur in the lab, because there's probably a couple we won't predict right, okay, because there's a couple that don't go the way we might think. Okay, and then in question number 2, it asks about the reactions that produce precipitates. So spoiler alert, there are a couple of reactions that make precipitates. Okay, you'll need to be watching out for those. Using your chemical equations and your solubility chart, you're going to have to figure out what the precipitates were. All right, so things to think about when you're doing the lab tomorrow. These are things that you're going to have to answer when we're all done. Okay, and then same as always, conclusion and sources of error. Okay, will also be involved there. Okay, so you may want to use your lab report template and kind of get things going on that tonight, and you'll have less to do over the weekend. Okay, for that one, because this one will be due, I would say, early next week. Okay, like Monday or Tuesday. All right, so make sure that you've got it all ready to go. Okay, questions, Seth? Can I jump to the other slide? Yes, this one or the other? Yeah. Okay, so again, that's what your chart should look like. I'm podcasting this, and I'll put it up, okay, after class today. So if you forget what the chart looks like, okay, just scroll to the end of the podcast and pause it, all right, and then you can make the chart like this one. Alrighty. Okay, so everyone will be ready to go for tomorrow. And again, your quiz will be posted shortly. Okay, guys, just quick review here in case anyone has forgotten how to make the chart in Google Docs. Okay. I don't really want that. Okay. All right, so in case anyone's forgotten here, you go to Create, and you go to Documents, right, and it'll bring up, okay, an untitled document. If you want to make a chart, you go Insert. Make sure it's in the right spot in your document. Table, right, and then it gives you this thing here, and you can make it however many rows by however many columns, okay, you want to make it. This one really just needs to be 1 by 2, right? So when you do that, you get this, and you can move, okay, the thing around in order to make one side bigger than the other. All right, and you just insert that into your document wherever you need to. Okay, Nick, question? Yes, but each person will be handing in their own lab report. But yes.